get that? So for example, you're going to have this one. So 3 raised to 2, you have 3 times 3. So this is equal to 9. So if you're going to have a trihybrid cross, and all of them are actually heterozygous condition, therefore, what do you expect? So what are, or how many genotypes can be formed?
3, 1, 2, 3.
Okay, so 3 raised to 3, so this is actually equal to 27. So you will be forming 27 different genotypes. Did you get that? But please take note, there is a condition here. You can only use the formula if all of them are actually heterozygous. You cannot use this formula having this particular mate. Okay? Okay, so you cannot use this formula having this particular parents. You can only use the formula if all of the parents has heterozygous condition. Did you get that? Okay, so same is true with the phenotype. The phenotype has the same formula as your types of the mates. Okay? So you have here 2 raised to n, please take note, wherein the n is still the number of heterozygous pairs. Did you get that? Okay. So for example, in this regard, so if we're going to use the formula 2 raised to 2, so you have here 4 different phenotypes. Are these correct? You actually get for the phenotypic ratio of 9 is to 3 is to 3 is to 1. Therefore, how many types or kinds of phenotypes? Okay, you actually have 1, 2, 3, 4 different phenotypes. Okay, so same is true if that is a dihybrid cross. So this is 2 raised to 3. Therefore, you're going to have here 8 different phenotypes. Okay, so you will be forming 8 different phenotypes, but this will have 27 different genotypes. But please take note, this is only true if all the gene pairs are actually on its heterozygous condition. Nakakaintindihan? Okay. So let's move on to the first topic on the probability testing. So this is said to be the chi-square. Are you familiar with this one? Not yet. Chi-square is actually the test for the goodness of fit. Okay, so you are taking your statistics at this semester. Okay. So chi-square is actually the test for the goodness of fit. So what you're going to evaluate with regards to the chi-square test for the goodness of fit. So what does it mean? You are actually testing in the chi-square if the observed values is equivalent to the expected values. Okay? So this is what you are trying to prove. If what you have observed is in line with the expected one. Did you get that? Okay? So with regards to the chi-square test, you are already familiar with the formulation of the HO. What is HO again? Null hypothesis. So this is a null hypothesis. And you have the formulation of HA, which is alternative hypothesis. Okay? So you have learned in your bias path that the HO is always a negative statement. Okay, so for example, there is no difference. Okay, that is a negative statement. And if you're going to have the HA, it is always on its positive form. Did you get that? Okay, so you already know you have practiced this one in your bias path. The formulation of your HO and the HA, not yet. And another thing to remember is that when I am asking for the probability, last time, I told you to write this one in fraction. Because probability is always from 0 to 1. Did you get that? So the values of probability is always from 0 to 1. But I used to accept when this is actually converted into percentage. But please take note, in statistics, probability would always have a value from 0 to 1. Okay, so that's why it's actually used in fraction. So please take a look on this one. So for example, you are actually given, so this is the problem, you are given the flower color. So how many traits do you consider here? In this problem? How many traits? How many traits? How many traits? Okay, you only have one, but you have two alternative forms. Okay, so what is the trait? Okay, so that is actually the flower color. And the alternative form would be white and purple. Okay, so in this regard, the problem would actually tells you if, for example, the problem would actually tells you that you have to evaluate if this observation fits the 3:1 ratio that you are expecting for a monohybrid cross. So if that is a 3:1 ratio, you are very sure that the cross is coming from what genotypes of the individual? If that is a monohybrid cross, so monohybrid cross, and you want to find out if the observation follows the 3:1 ratio of Mendel. Therefore, you are very sure that if this is a monohybrid cross, because you are only dealing with one trait, you are very sure that the genotypes of the individual are heterozygous. Okay? So let's have here heterozygous by heterozygous, or let's use a W for the word. So heterozygous by heterozygous, therefore, you are actually expecting for the production of a genotypic ratio of 1 homozygous dominant, 2 heterozygous, and 1 homozygous recessive. But please take note on the phenotypic ratio, you have here 3 white and 1 purple. Okay? So you would like to find out if the observation does follow your 3:1 ratio for a monohybrid cross. Okay? So what is actually given? You have there 290 white and 110 purple. Okay? So if this one is being followed by your observation. Did you get that? Okay, so let's have first the null hypothesis. So the null hypothesis here says that the observed values are close to the expected values. Thus, the observed values for the flower color follows the 3:1 ratio. What do you observe with my null hypothesis here? As I define the null hypothesis on the previous lecture, do I confirm the same definition as I have mentioned it to you? No. Okay? But this is the null hypothesis that I want to state. Can you make the negative statement but without altering the meaning of my null hypothesis? Or anyone? Because this is actually on its positive statement. The observed values are close to the expected. Thus, the observed values for flower color follows the 3:1 ratio. That is a positive one. How can you make this one a negative statement without altering the meaning? Oh, when you say it's not close, it's already, you're altering the meaning, which is close. Oh, how are you going to do that? Anyone? Oh, plus one.
Not far from the expected value.
The observed value is not far. Okay. So the observed value is not far. Okay? Or any other aside from this one?